Hello everybody, and welcome to our next OSPF video. And I figured before I got into the configuration between Area 1 and Area 19, I thought I would take a moment and go over the areas themselves as to why you would need them and why I was having so many issues in the last video getting it to work. And normally, I've never had that problem in typical implementations, whether it's been in the real world or GNS3. But what I realized is the process can hang sometimes when it's been sitting for a while, and it's because it's a software application. Sometimes it doesn't work quite the way it's supposed to. So that's why I was like, I'm glad I restarted the process, because then I was able to propagate the routes. But and that's one thing that you're going to find during your implementations, where you might have to go just about to the ends of the earth to try to get it to work, and you might be, I just couldn't figure out why, and then all of a sudden I was like, well, we'll just clear the process on another router. So, but that comes down to the understanding how the process and the protocol works, because then if you know what it's doing, you can kind of think, okay, what else could it possibly be? And if you don't know the protocol, you're going to run into problems. So when we get into the troubleshooting section, I'll go over some common things that you might want to check for, and then I'm going to implement a few issues into the topology in various areas, so that we have to, that'll be more like trouble tickets that you might get in the real world, and be like, okay, this is broke, or this isn't working, or end users are complaining about X, Y, Z. This is the symptoms. Based on the symptoms, this is where I would look, and kind of make you think about it. But the areas themselves can be a pain in the butt to troubleshoot if you don't understand why they do what they do. So, according to what I've read and what I understand, areas add hierarchy and scalability to the routing domain. An area defines the flooding domain. All devices in the area agree on the topology. Changes inside the area require LSA flooding and full SPF. Routing between areas hides topology details. Inter-area routing similar to distance vector. So it only knows about what's going on. It's only going to know what the border router tells it. So changes outside the area don't always affect or don't always require LSA flooding or SPF. Limits impact on router resources. Now, if you make a change on a route, like you change the cost or the bandwidth on a link or something like that, there's a thing called a PRC, or a partial route calculation, that, let's say for instance in area 0 we change the bandwidth on one of the serial links going from a point-to-point connection, not the frame relay side, but one of the point-to-point connections, say between router 7 and router 8. If we were to do that, then that would trigger an LSA update, because something's different about the LSA now. The link is different than it was before. So that it would propagate down to the DR on that link, which the DR is then a border router at the same time. That border router would then propagate a partial update to Area 1 because the cost has changed. Then that would trigger a partial route calculation, but it would only trigger an update on that particular link. It wouldn't cause for a full SPF calculation, or at least it shouldn't. It depends on the size of the network. So there's a couple area types that we have to talk about. The first area is the backbone area. This is always going to be area 0. Used to summarize topology information between other areas. You can only summarize on border routers and ASBRs. So ABRs and ASBRs. ABRs are area border routers. They are the routers that sit between two areas. So 6 and 8 are area border routers because they border on area 0 and area 1. ASBRs are the routers that border up against a OSPF flooding domain, so like in our case area 1 and potentially area 19, because one of the links or the router that's going to connect to router 9, router 10, could be connecting to that server in the corner via EIGRP. So even though there's no routing configured there, as long as you have a router that can peer with it, the potential is there. So, and we'll check that out. We'll get that situated and show you what that means. But the idea is, with Area 0, all traffic must pass through it. So it's a backbone area. So it's it's transit. So it must be contiguous. Everybody must connect to it. Non-transit areas, all other areas, 1 through whatever. So it's a 32-bit field. So it's 1 through all 255s, as you can see. Must use connections to Area 0 to reach other areas. So that's by default what it should be. Now, the router types. You've got the backbone routers, which are at least 1 link in Area 0. So you have quite a few backbone routers. Internal routers, all links are 1 non-transit area. So internal routers are going to be things like things in Area 1. If it was just kind of hanging there and not providing transit for something else, like a stub router. A stub router would be more like R10, where it doesn't connect. It's not connecting 2 routers together, and it's not performing transit for, say, router 11 to talk to router 9. So there's not the middleman. An ABR is an area border router, like I said, and what this does is it has at least 1 link in Area 0 and 1 link in a non-transit area. Uses summarized information between Area 0 and the non-transit area. So the ABR is going to be like a translator, if you will. ASBR, Autonomous System Border Boundary Router, has at least 1 link in the OSPF domain and at least 1 link outside the OSPF domain. So that could be running EIGRP, BGP, whatever. Used to redistribute information to or from other routing information domains in OSPF. So if you're going to be running EIGRP between 2 links, you could very easily set it up to be a router that connects between EIGRP and OSPF. But you would need another router to complete the peer, and then you'd be able to go from there. But topology example, what this means basically is this: you have ABR, so Area 0 is the pink, Area 1, 2, and 3 all connect back to Area 0. So ABRs are the border routers. Remember, area border routers, or ABRs, need to have at least 1 link in Area 0 and 1 link in any other router or any other area besides Area 0. And ASBR is like the one in the lower right hand corner, where you have EIGRP sitting there, and then you have the connection off to Area 2. So Area 0 continuity. All inter-area traffic must pass through Area 0. If a non-transit area loses connectivity to Area 0, all inter-area connectivity is lost. This state is called discontiguous or discontiguous Area 0, meaning you don't have a direct connection back to Area 0. Repairs to these broken designs come in the form of virtual Area 0 adjacencies called virtual links. It is a tunnel